Hi class. Today's lesson is lesson 3-5. It's on multiplying decimals. Let's go ahead and take a look at the purpose. Our purpose for this specific lesson is to multiply decimals by whole numbers and other decimals. There is no vocabulary for today. I do want you to write down example 1 and a little bit of background. I will tell you exactly what you need to write here. But let's go ahead and read what we have here. It says, because the moon has less mass than the Earth, it has a smaller gravitational effect. An object that weighs 1 pound on Earth weighs only 17/100ths of a pound on the moon. So things seem lighter on the moon than they would be on Earth. You can multiply the weight of an object on Earth by 17/100ths to find its weight on the moon. A flag weighs 3 pounds on Earth. What is the weight of the flag on the moon? So on the next slide, we're going to take what they've given to us. That is the information that 1 pound on Earth is equivalent to 17/100ths pounds on the moon. And we're going to solve this problem. This particular sentence right here tells us that you can multiply the weight of an object on Earth by 17/100ths. And so we're going to use that information on the next slide. Here's where we're going to have to do some writing. Here's the same problem. A flag weighs 3 pounds on Earth. What's the weight of the flag on the moon? So the story problem indicated that we just go ahead and take pounds, multiply it by 17/100ths, and we'll get weight on the moon. Of course, the P means pounds on Earth. Okay, pounds on the Earth. So if something weighs 3 pounds on the Earth, what's the weight of the flag on the moon? So let's construct our problem here. Instead of the variable P, we're going to substitute 3 pounds times 17/100ths. That should give us what the weight is on the moon. Now, first thing we do, of course, before we actually solve this problem is figure out what is an estimate of this. Now, I know that 3 times 1 is equivalent to 3, and 17/100ths is much smaller. In fact, it's almost a tenth smaller than this 3, so I know my answer is going to be much less than 3. So I'm going to write that as an estimate here. It's going to be less than 3. In fact, it's going to be much less than 3. Now, moving on to how we actually do this. First of all, I'm going to go ahead and put this problem into column form. 17/100ths times 3. How do I do this? Well, let's take a look at some steps that we can take. And those steps include, number 1, multiply as if the numbers were whole numbers. Okay? So I ignore the decimal and I just multiply this as if it was 17 times 3. 7 times 3, or 3 times 7, is 21. 3 times 1 is 3, plus 2 is 5. That's 51. Our second step is count the total number of decimal places of both or all factors. Let's go ahead and count here. We've got a total of 1, 2 place values for this factor, and there are none for this. So there's a total of 2 place values. So what we do then is, on step number 3, product will have the same number of decimal places. So for this answer, we're going to move the decimal point over 2 places. How do we do that? Well, we know that the decimal place for 51 starts here. It's going to be less than 3, so we have to move toward the left here, 2 decimal places. Decimal, There we go. So our answer is 51 hundredths of a pound is what that weighs on the moon. Boy, that is small. There we go. Let's take a look at some other examples. And notice for each of these products, we have to do some estimation first. Let's look at 2/10 times 6/10. Let's go ahead and put that in column form. I have 2/10 times 6/10. Now, before we do this, let's go ahead and estimate. I know that 2/10 times 1 would equal 2/10 because a number times 1 equals itself. And I know that 6/10 is smaller than 1. So I know in actuality my answer is going to be less than 2/10. Oops. It's going to be less than 2/10. Now, I take the steps. I'm going to treat these as if they were whole numbers. 2 times 6 is 12. Then I'm going to count the total number of place values. Here's 1 to the right of the decimal. Here's another to the right of the decimal for a total of 2. That means I need to move that decimal point back to place values. Now I look at my answer, and it is 12 hundredths. Is 12 hundredths less than 2/10? Well, the way I'm going to check that out is put another 0 there. Is 12 hundredths less than 20 hundredths? Absolutely. So my answer is definitely 12 hundredths for this one. Number 2, I'm going to estimate here again. In this case, I've got a 3 and 25 hundredths times 4 and 8/10. I'm just going to do a little bit of rounding here, and I'm going to say, well, that's going to be around a 3 times 4 and 8/10 is around a 5, so that's around a 15. Okay, 3 times 5, 15. So my answer is going to be around 15. What I'm going to do then is I'm going to go ahead and stack this up. 3 and 25 hundredths, 4 and 8/10. Multiply this out as if they were whole numbers, ignoring the decimal points. Notice I'm not lining up the decimals here. I am just simply pretending that they are whole numbers at this point. I'm keeping the decimals in there, but I'm just treating them as whole numbers. So 8 times 5 is 40. 8 times 2 is 16, plus 4 is 20. 8 times 3 is 24, plus 2 is 26. Then I go to the 4. 4 times 5 is 20. 4 times 2 is 8, plus 2 is 10. 4 times 3 is 12, plus 1 is 13. I'm going to go ahead and lower the 0. Lower the 0. 6 plus 0 is 6. 2 plus 3 is 5. And 1 drops down here. Now I have 15,600 is what it looks like. But in actuality, I've got to count how many decimal places I have. And I have 1, 2, 3 total decimal places to the right of the decimal point. So with 3 decimals places, I move this over 3, 1, 2, 3. And my answer is 15 and 6/10. Now is 15 and 6/10 close to 15? Absolutely. So I am going to go ahead and keep that as an answer. We're going to go ahead and skip over this particular one and hit the one of these examples, and I'm going to go ahead and choose to do this first one. Here it's simply a matter of algebra, evaluating for 3x. So I'm going to put 3x here, and then it's going to say I want you to substitute x with 4 and 47 thousandths. If I do that, my problem becomes 3 times 4 and 47 thousandths. Once again, I'll estimate, and my estimate over here is 3 times 4, which is going to be around 12. I'm going to go ahead and lay this out as if they were whole numbers, but keep the decimal in there. 3 times 1 is 21. 3 times 4 is 12, plus 2 is 14. 3 times 0 is 0, plus 1 is 1. 3 times 4 is 12. Now, how many total place values do I have? Well, I have 1, 2, 3, and none here. So I have a total of 3 place values, which means I move that decimal point over 3 place values so that my answer now is 12 and 141 thousandths. Is that close to 12? Absolutely. Your work for tomorrow is to tell how many decimal places are in the product of 235 and 2/10 and 24 hundredths. Total decimal places we're talking about. Now we're going to ask you to show how to use a distributive property, 1 and 7/10 times 2. Now this is a relatively difficult one. I want you to give it a try though. And then I want you to go ahead, and this is a good one, describe how the products of 3/10 times 5/10 and 3 times 5 are similar. And then you're going to describe how they're different. So you're going to have to solve those pretty simple problems. All right, we'll see you in class.